Our speaker is a marine mammal zoologist. She studied at UBC and was a member of the Marine Mammal Research Unit. She studied Harbour Porpoise seasonal abundance, diet, incidental catch, and behavior. She's conducted research in British Columbia, Washington, Mexico, and Alaska. And her research focuses on addressing data gaps related to a variety of marine mammal species.
I may in fact be the only person in British Columbia that had not heard of the book series. And I was thinking about the shades of gray as it relates to Harbour porpoise, which have beautiful shades of gray, as does the aquatic environment that they live in. I will talk about the sexual behaviors of Harbour porpoise, but we'll leave that for a few minutes and get into some other aspects. And it is not. Now, Harbour porpoise are a species for which there are some real perceptions or perhaps misconceptions. And even as a student at graduate school, I heard a number of times that these are rather dull and particularly uninteresting mammals. And I hope by the end of this talk that I have changed your perception of Harbour porpoise, because I truly believe that they are totally wrong when it comes to these animals. Harbour to think of sort of English Victorian society, which up front and on the cover appears very reserved and perhaps a little standoffish. But if you scratch beneath the surface, you see a life that's full of all kinds of parties that go on until 2, 3, 4 in the morning of the very next day, and all kinds of things that on the surface would never be readily apparent. And Harbour porpoise are just like that. So if they are so interesting and they have these interesting lives, why do we know so little about Harbour porpoise behavioral ecology? And for this, I would like to defer to a non-mammal, because it's really not easy being gray. As a porpoise biologist, this is what I strive to see. That's what I usually see. And then I see that, and I think, is it the same two animals? Is it two different animals? And what are they doing? Why were they going the same direction in the first sighting, and now they're going in two different directions? What is going on? And remembering that these are animals that spend less than 5% of their lives at the surface. So I spend a great deal of time doing this, sometimes this, to try and get to this. This is porpoise biologist nirvana. Beaufort zero, or as we refer to it on the boat, Beaufort awesome. This is what we try to maximize. So that we can ensure that we make use of every moment of Beaufort awesome, I have to spend a great deal of time reading and searching the literature so that I can try and learn everything there is to know about these animals. So I spent a lot of time in the library because a lot of this stuff isn't online. And I thought, I can't start at the very beginning. I have to build on somebody else's behavioral framework. And so I used the framework of J.P. Scott, and this goes back to 1958. And he studied animals extensively, all kinds of animals, from sponges to cows to domestic dogs to you name it, he studied it, camels. And he decided that you can talk about animal behavior and you can group it into a number of categories. And remember, this is going back to the 40s and 50s, so the language is a bit different. Ingestive or foraging behavior, shelter seeking, we call that habitat selection now. Sexual behavior, shades of gray, we call it now, it's a bit different. Agonistic, aggressive behavior, epimelectic or caregiving behavior. This is hard to say, epimelectic, care soliciting behavior, allelomimetic, group behavior when one animal stimulates another animal to do something else. Birds flocking would fall into this category. Eliminative behavior, probably don't need to translate that one. Investigative behavior. And I added to this framework avoidance behavior. For Harbour Porpoise, I think this is particularly relevant. Social behavior. And I must say, when I added this in at graduate school, I had a few raised eyebrows around the table. Harbour Porpoise? Social? Are you sure? I'm sure, I said. And then rest and sleep behavior. And I have actually spent enough time on the water that I've seen more than and it's a very difficult thing to find. Just so that we're clear, I'm not going to go through every single one of these categories tonight. Okay? We would be here until midnight. I'm going to focus on the first three. And the reason for that is if you don't eat, if you don't have anywhere to live, and you don't reproduce, the rest of it's kind of pointless. To me, these are the most important for conservation. Why did I build on the framework that John Paul Scott put together? Well, he's a particularly clever chap. He spent a great deal of time thinking about these things. He was recognized by his peers, wrote more textbooks than I could hope to even accomplish in my lifetime. And more importantly, he recognized that animals are clever. Some animals are very clever. Others, a little less so. But he incorporated this thinking and selection and choice ideas about how animals make a living. And in fact, he wrote that the great majority of animals seem to have definite preferred localities around which they spend most of their lives. And these are usually the places where they were born and where they grew up. So if we think about how we define if animals are clever, if they're intelligent, we tend to look at their brain size to body mass. And certain small odontocetes rank very highly. Harbour porpoise are very smart. So these being clever animals, animals that think, I think animals that are quite social, to me it made sense to move forward and try and understand in British Columbia some of the key aspects of these fundamental life processes of foraging, habitat selection, and how they go about producing the next generation. This is what I was thinking of with shades of gray. Turns out I'm the minority. This isn't what anybody else was thinking about with shades of gray. And I used to say to my crew on the boat that I see porpoise. I see porpoise everywhere because it's what I think about. I think about how they capture food, how they select their habitats, and how they reproduce. Now, as I said, I spent a great deal of time so that I could maximize Beaufort Awesome by finding out what other people knew and what other people had written about Harbour porpoise. And I decided, why limit myself to British Columbia? That would have actually been a very fast literature review, probably could have had it done by the first coffee break of the day. I looked at the entire range of Harbour porpoise, and you can see it here in the Northern Hemisphere, circumpolar in distribution, 3 subspecies, possibly 4 with the Eastern and Western Pacific Ocean still being debated as to whether or not those are different subspecies, pardon me. And I was able to find information from the mid-1800s to the present day. That was the bulk of it. But some records went back as far as 1680. So with regard to their foraging behavior, and this is often what we see in the wild and we call foraging. But after my literature review, I realized that our definition of what foraging behavior looks like is far too narrow. So here's a porpoise. Is it foraging? Is it escaping a transient? Is it just having fun? Perhaps it's a juvenile. Chasing a fish, chasing a squid, we don't know. Very few people have actually ever seen Harbour porpoise ingest prey in the wild. But what we do know from inferential studies based on diving, surface observations, and in some cases stomach contents analysis, that these animals spend approximately 3/4 of their time pursuing and consuming prey. We know that they have both solitary and cooperative behaviors. They eat pelagic and benthic prey, and it's interesting that it appears to depend on what is most abundant. If they're in a shallow area with lots of bottom prey, that's what they will focus on. If they're in an area with lots of pelagic prey, that's what they will focus on. It's interesting that most of the records of foraging Harbour porpoise discuss very small groups, single animals, ones, twos. But back in 1959, when things were written very descriptively, there was an observation of several hundred Harbour porpoise cooperatively encircling and capturing sardines off the coast of California. And I really think this is lacking in our literature today. We are so focused on the experimental design that naturalist observations are being left out. In the older literature, we do see these. This was the only record from the Pacific of very large numbers of cooperatively foraging Harbour porpoise. But when we look at the literature from around the world, foraging is described as animals that fast surface, animals that zigzag, animals hunting in crescent-shaped formations or half moons, animals chasing prey in straight lines, and even milling. So clearly, much remains unknown of the foraging behavior of Harbour porpoise. So I decided, right, let's try and figure this out a little bit more. And I developed a hypothesis that porpoise, because they're going to spend approximately 3/4 of their time hunting, they're going to want to be in very productive habitats. Productive habitats tend to be those that are quite well mixed. And so my hypothesis was that porpoise are going to use very localized areas of increased tidal mixing as temporary but predictable foraging arenas. Because remember, these are clever animals. Very large brain size compared to their body. We also know from captive studies that Harbour porpoise, in particular, maintain mental maps of their habitat. So it's one of the key things when it comes to echolocation. Do they echolocate all the time? No. Do you use your GPS in the car to get to the grocery store? Not in your home neighborhood, probably, because you know your way. You have a mental map. Harbour porpoise also have mental maps. And in which case, it seems to me quite reasonable to consider that these animals would then also be able to have some way of understanding what's going to happen in their environment as related to the tide and their physical oceanography if they are living in fairly small habitats. So I went off to the Institute of Ocean Sciences in Sydney, BC, and spoke with some very clever physical oceanographers who helped me understand what the water looks like off southern Vancouver Island. And this is an image based on Mike Foreman's tidal model, which is a published tidal model that is for all of British Columbia. The red areas, red and orange, indicate high levels of tidal mixing, and the blue and purple areas indicate low levels of tidal mixing. So right about where the word but is, on there, is the city of Victoria. So that's southern Vancouver Island. So you're looking at Juan de Fuca Strait and Harrow Strait and the junction between the two. So you can see right away there are two very large areas of tidal mixing, increased tidal mixing. So over those two red splotches, I set up a grid pattern I've done for my PhD research. And I collected data systematically in these two regions for 1 year using a point transect protocol. And this was actually the first point transect protocol used for Harbour porpoise research anywhere in the world. But for understanding behavior, to me, it made a great deal of sense. And this is something that was adapted actually from terrestrial studies, in particular with birds. And I limited all my observations to Beaufort Awesome, Beaufort 0 to 2. So for those of you who don't spend a lot of time on the water, flat as glass to a gentle ripple. Beyond that, you really cannot see a Harbour porpoise in the wild very well. This was the research vessel. We had 2 observers, one stationed forward, one stationed aft. But I was also lucky enough that I spent time working on a whale watching boat. And I worked my way from the deckhand, as a deckhand on the small boat, to the captain of the big boat. And I think I was the only commercial captain who probably should have had a bumper sticker that said, "I break for porpoise." Because there could have been southern resident killer whales 2 nautical miles away, and my boat would have stopped at 3 Harbour porpoise so that I could make observations and try and figure out what they were doing. So what I'm going to show you here are the results of the study, keeping in mind that there are 2 types of data, the systematically collected data and the opportunistically collected data. So dedicated research vessel, whale watching boat. I looked at the number of Harbour porpoise that were seen on the differing tides. And here you can see for area R, that was one of the red splotches off at southern Vancouver Island, showing the flood, ebb, and slack tides and the counts of porpoise. And quite clearly, there was more porpoise seen in that area on the ebb. And area D was the second red splotch off Discovery Island. And again, more animals seen on the ebb tide, so the outgoing tide. In those same areas, observations from the whale watching boat, we see, again, more animals seen on the ebb tide, the outgoing tide, not quite as different, but in area D, quite a fair number seen on the outgoing tide. So it's the trend that's important here. So that, okay, well, if we think about the tides, what drives the tides? Well, it's celestial events. It's the moon and the sun and the earth and our relative positions. So let's look at the spring and neap tides. The spring tides are on the full moon and the new moon, and the neap tides are on the quarters. Spring tides, spring is actually a word that it doesn't mean the season, it means activity. And in the ocean, on the spring tides, we get a great deal more activity because we have increased rates of mixing because our currents are stronger. So let's look again. Area R, again, this is a systematic area, race rocks, one of the big red splotches. More animals seen on the spring tide than the neap. Area D, second red splotch, systematic data, again, more on the spring. The supplementary data, both areas, we see the same trend again. And in this case, the differences between the spring and the neap tide are fairly large. In fact, they are statistically significant. If we look at the lunar effect, we compare all four phases, the new moon, the full moon, the first quarter, and the last quarter. This is the systematic, the point transect data compared to the supplementary data. And again, it's the trends. The trends are very similar, and they are statistically significant. So there are tidal and lunar relationships that relate to porpoise foraging. These animals do change their foraging behavior, at least in southern British Columbia, as it relates to the tide and the lunar cycle. And it was interesting to me that it was the ebb tide, because I had envisioned in my head the flood tide coming in from the open ocean, bringing all those lovely nutrients into the Strait of Juan de Fuca and Haro Strait. But it wasn't. It was the outgoing tide. And I spent ages going through and ensuring that the math was correct, because I thought, well, how could that be? Again, I took myself off to the Institute of Ocean Sciences, needed to talk to those in the know, the physical oceanographers. And it turns out that you have to also take into account the rotation of the Earth. I had forgotten. When you take into account the rotation of the Earth and you look at the strength of the currents coming in Juan de Fuca Strait, up Haro Strait, and into the Strait of Georgia, near where we are now, on the outgoing tide, because of the rotation of the Earth, the water is pushed against Vancouver Island. So there's a slightly increased water volume, but the speed also increases. So not only were the animals selecting the areas of the highest tidal mixing, they were also specifically selecting not just flood and ebb tide equally, they were moving in on the ebb tide. It would be very interesting to do the same study on the American side and see if we get the same trend, but on the flood tide. It was also interesting that the animals were facing into the current. And we saw repeatedly groups of animals that would move their way through areas of very rapidly moving water and then suddenly disappear. And you think, here we go again, where are they? But what would happen is they would suddenly reappear downstream and then move their way into the current and then disappear. And I think what they were doing was using that water, the current, as almost a conveyor belt of food as they move their way through the prey column as it's being brought towards them, dropping down. We know that whales and dolphins use gravity to help them dive. Why wouldn't they allow the current to help them forage? It would be a nice break if they move back. It would be very interesting to get some telemetry data to see if, when they're in these very localized areas, if they are allowing the current to push them back to where they want to be. And it was also interesting that foraging was social. We very rarely saw single animals. Not only did we see groups of animals, but we saw increased numbers of animals in the group size. So the use of the areas was stable over time, and the group sizes were stable. And we saw calves. And so these particular areas, these discrete little localized areas that are predictable because of the currents and the tides, and as the moon moves its way around the Earth, that this may in fact hold intergenerational significance, which brings us to habitat selection. or shelter seeking, as Scott called it. If Harbour porpoise spend 3/4 of their time foraging or in pursuit of prey, then it makes sense that their seasonal, reproductively selected habitats, these areas, as Scott put it, they are going to center their lives around where they were born and where they grow up, would also offer them enough food, that they wouldn't have to then make great excursions to go and feed and then move back into these reproductive habitats. So, do we know, do Harbour porpoise have seasonally selected reproductive habitats? Well, in the Atlantic Ocean, most certainly. In fact, we have rather good evidence for traditional breeding and calving habitats that dates back now to the late 1800s, published in 1900 in the North Sea, where females were reportedly bringing their calves, their very, very young, into waters that were knee-deep in the North Sea. We don't see that anymore. In the Bay of Fundy, in the 1970s, females were reported bringing their calves into the area of Deer Island. In the Baltic Sea, my goodness, we've got lots of examples of traditional breeding and calving habitats. Germany has now designated the area around the island of Sylt as traditional Harbour porpoise breeding habitats, and it's protected. Denmark has them. Ireland has them. There must be more. And so I thought, well, what about British Columbia? So I decided that, as I mentioned earlier, that proximity to these feeding areas must be important for the reproduction of the species, especially when we consider that in captivity, Harbour porpoise do not do well if they don't feed. They are not like some of the larger whales that can withstand periods of reduced caloric intake or even starvation. Harbour porpoise are a bit like hummingbirds. They have to eat, and they have to eat regularly, or else they simply expire. And reproduction is energetically expensive. So one would think they might even need to eat more during the reproductive season. So I developed a couple of hypotheses that the Harbour porpoise were going to use these same areas of increased tidal mixing that I already knew that they were using to forage in, and that the densities during the reproductive season were going to increase in these regions. So I limited my study to southern British Columbia because that's where most of the data are. We have very little data for central British Columbia and almost nothing for northern British Columbia. But I was able to amass a multi-source data set that spanned from 1991 to 2008. And in that, I had 11,458 Harbour porpoise sightings. I didn't collect all of these. I collected some of them, and I was lucky enough to have other people donate their sightings to me. And within this multi-source data set, the group size ranged from single animals to more than 250. And I looked at the interannual use of areas, the presence of calves, presence of hybrids, and the presence of high densities. Again, thinking back to that 1959 observation off California with hundreds of animals seen feeding in one area. And yet, for most of the literature about Harbour porpoise, we don't have discussion of high densities. But I had seen them off southern BC, or in southern BC, so I thought, let's look at this statistically. So my study area was pretty much all of Juan de Fuca Strait and almost all of Georgia Strait, and the encompassing areas in between. It encompassed a total of 37,000 square kilometers. April to October was the time I looked at, because that's, according to the literature, when we should be seeing reproduction in this species. And within that multi-source data set, there was both opportunistic and systematic data, but the systematic data totaled more than 156,424 kilometers worth of transect effort. So what did it look like? Okay, and I have to be very clear here. Harbour porpoise do not swim in straight lines like this, okay? The lines that you can see here, those are the transects. Those were observations made on aerial transects that the US government gave to me to add into this data set. So I statistically looked at the patterns that occurred within this multi-source data set. And I looked at it, each data set independently, but also collectively. And using a series of statistical analyses, we found important areas. And actually, I have to say, we also looked at Dall's porpoise as well. And out of that entire region, all of Juan de Fuca Strait, up through the islands in Georgia Strait, there was 175 square kilometers that were deemed important for Dall's porpoise based on spatial patterns. And for Harbour porpoise, even less, 150 square kilometers. That's what statistically came out in the pattern recognition of this is where you're going to get your highest clusters. So I wanted to look at what are those habitat attributes. Thinking back to Scott's shelter seeking or habitat selection, what are these animals queuing into? We always say Dall's porpoise prefer deep water, Harbour porpoise prefer shallow water, but what does that mean? Well, it actually is quite a significant difference. The Dall's porpoise are in black, the Harbour porpoise are in gray, yet another shade of gray. Harbour porpoise, you can see that zone between 51 to 100 meters, that was it for them. Quite different from the Dall's porpoise, and also quite interesting when you think there are only 6 species of porpoise on the planet. British Columbia has 2 of them, and they live side by side. And here we can see how they're partitioning the habitat based on depth. But if we look at tidal speed, and again, this is Mike Foreman's model from the Institute of Ocean Sciences, showing a slightly larger area, but again, the red and the oranges tell you that it's rates of increased tidal mixing, whereas the blues and the purples are the lower rates. And the two, the oval and the circle, are the areas that were statistically identified, Dall's porpoise being the north one, Harbour porpoise being the southern one there. What does it look like when we look at the rates of tidal speed in those really select habitats? Harbour porpoise here are in gray, and Dall's porpoise are in black. And I would have guessed it the other way around. The very strong, muscular Dall's porpoise weighing in at several hundred pounds more than the little petite, frail, perhaps not that interesting, retiring Harbour porpoise. Oh, that's right. Who's in the fastest going water? The little Harbour porpoise. They are selecting the fastest moving water in those zones, which, considering that they're going to spend 3/4 of their time foraging, if that's what they're using, if they're using the biophysical properties of the ocean to help them, which kind of makes sense, they're moving into those really key areas. But what does this mean for calves? Because I told you that this was really thinking about the reproduction of the species and habitat selection. If we look at those 2 zones again, and we look at the calves that were reported to me in the multi-source data set, 49% of all of the Dall's porpoise calf sightings fall within that oval, and 41% of all Harbour porpoise calf sightings within that very small 150 square kilometers encompassed by that circle. What about the high densities? What about big numbers? Because if you're going to be breeding, you want to have lots of potential mates around you. So what does high density mean for Harbour porpoise? Who knows? We'd have to ask a Harbour porpoise. But I decided, let's have a look at group sizes greater than 15. Well, 67% of all of the groups in that multi-source data set over those 11,000 sightings between Harbour and Dall's porpoise, 67% of the group sizes greater than 15 animals fell within that 150 square kilometer circle, and for Dall's porpoise, a little bit less, 57%. What about if we really up it? What if we say, right, reproduction takes place when you've got the maximum group sizes, so let's say more than 50 Harbour porpoise or Dall's porpoise in one area. Now what does it look like? 100% of the Dall's porpoise large groups at 50 animals or greater fell within that circle. And for Harbour porpoise, it was 3/4. 74% of all of the large groups were in that tiny little area, which incidentally, as you can see here, is on the border between Canada and the United States. Anybody who's ever sat either in a boat or on shore looking out to Harrow Strait, Juan de Fuca Strait, or even Strait of Georgia will know it's a very busy area. That circle intersects one of the busiest shipping lanes in the province. So how does it shape up if we're talking about seasonality? Well, you can see the biggest groups are in May, and then again September and October, a bimodal distribution. And that's quite interesting because we think Harbour porpoise give birth in the spring, and then a few months later will mate. If we look at calves, well, that makes sense. If they're giving birth in the spring, we're going to see more calves because Harbour porpoise newborns are very small. We get our peak sighting rate of calves in July, August, and September, which makes sense. The animals are growing, and we're able to see them in anything greater than Beaufort 0, Beaufort Awesome. 98% of all calf and all high densities fell within this time frame, the April to October. And 100% of the hybrids were observed in this time frame. And that's interesting because we think about hybrids and we're not sure how viable they are. Do they make it to subadult? Do they make it to adulthood? But we're looking at young animals that were usually with their mothers, and they were exclusively seen April to October in the data set I looked at. So what does this mean? Well, I think it means that we've found the first identified traditional breeding habitats for porpoise in the province. And in October 2010, after the study was completed, look who was seen right in the middle of the Harbour Porpoise circle that we identified within that really important 150 square kilometers. And I've thrown this in just because I like all porpoises. In January 2011, so winter, within the area identified for Dall's porpoise, you can see that little fin. Does that mean that the area that we identified during the reproductive season may also serve as a wintering nursery area for Dall's porpoise? And that was actually proposed a few years prior by Jefferson, that perhaps Dall's porpoise would have wintering areas that are productive, because Dall's porpoise males have a very different strategy when it comes to mating, which we're going to get into next. The females would want to stay away from the males when they're getting reproductively active. But if these areas are good for foraging, wouldn't it make sense to take your calf into that most productive area, especially during the winter months? So the key points here in British Columbia, we can say that April to October is the reproductive season. We have, I believe, identified the first breeding sites in the province, and that Northern Harrow Strait may also serve as a wintering area for Dall's porpoise for a nursery. But, and I saved this for last because I know it's after dinner, it's evening, it's dark, but what about the other shades of gray? Male Harbour porpoise, small, gray, maybe 60 pounds when fully grown, not that many claims to fame, really. 6-inch dorsal fin, doesn't display at the surface, doesn't have the big tall fin of the adult male killer whale. They do have testes, as do all males, but during the reproductive season, they have very large testes that account for 3 to 6% of their entire body weight. So we'll just do a bit of mental math. If the animal weighed 100 pounds, could be up to 6 pounds. So what do you think they think about during the reproductive season? I'm thinking it's females. And this falls in line beautifully with what we were thinking earlier, with if you want to have the species carry on, you want to find mates, you're going to go to the high density areas. But if you're this active, you definitely want to have a food source nearby. So what do we know about courtship behavior? Well, we do have some records from captivity that Harbour porpoise, during courtship, will chase each other. They will swim close to each other, push each other, swim quickly. But interestingly, they will also keep in contact physically for as long as several hours. And the males do a lot of posturing. Well, that's not a surprise given the amount of testosterone that's probably going through their bodies. But so do females. And we know that males also will gently bite the females on the dorsal fins and the flippers. And this is quite interesting because on stranded animals, we do see some significant scarring on some of the older animals, and we've never really known what it's from. Perhaps it's from reproduction. That is known from other cetaceans, perhaps Harbour porpoise. But what do we know? As I mentioned, this is about captive animals. What do we know about wild Harbour porpoise mating? It's an entirely different shade of gray because we know nothing. Except I just found out, just several hours ago, that there has been some brand new research coming out of San Francisco Bay, where if you didn't know, Harbour porpoise used to exist, didn't exist, and now have come back. And it turns out you can stand on the Golden Gate Bridge and have perhaps an adult viewing of Harbour porpoise. And there have been some phenomenal new discoveries about what these animals are doing, which are just coming into the literature and the scientific forum now. But what we do know is that these male Harbour porpoise, with all that testosterone, are sometimes a little non-selective. That's not a Harbour porpoise next to a Dall's porpoise. That's thought to be a hybrid offspring next to a Dall's porpoise. And you consider the size difference. Female Dall's porpoise, several hundred pounds. Male Dall's porpoise, 65 to 70. They're obviously very energetic and moving into those other habitats, the deeper waters.
Is that male Harbour porpoise or male Dall?
Hybrid. That's a hybrid with what's thought to be its Dall's porpoise calf.
You said female Dall's porpoise, 300 pounds.
Male Harbour porpoise, yes, yes, much smaller, much smaller. They're quite different. When we look at Dall's porpoise, the males are bigger than the females. When we look at Harbour porpoise, it's the other way around. Females are larger than males. So what does this tell us? Well, I think Harbour porpoise, being as clever as they are, have got far more than one foraging strategy. I think they're probably very complicated. I think it depends on what's going on with the physical oceanography of the region, what's going on with the biological oceanography, what are their preferred prey species. We know from stomach contents analysis in British Columbia and in other places around the world that very often you will get a single species in the stomach contents, which tells us that the animals move into a prey patch and they are feeding as much as they can. And we know from captive studies that Harbour porpoise will come up to the fish and with their tongue move it very quickly, creating a negative suction in their mouth and suck that fish in, and then with their tongue manipulate it around so it's head first and then suck it down their throat. And if you look in the stomach of an animal that has died while it's been foraging, you open up its stomach, you see fish lined up perfectly, all in the same direction. So these are the hoovers of the sea. They are going out, getting into these prey patches and getting as much as they can. Might explain as well why they do get entangled in fish nets as often as they do. If they're so focused in on foraging, they may not be echolocating far enough ahead to detect the danger up ahead. We also know that if you read about Harbour porpoise, they're often described as widespread, depending on who's written it, commonly seen in some areas. But important areas for the animals that are critical for survival, might be very, very small. And there are probably more of these throughout the province, but we don't know where they are. And they do have very specific habitat preferences. So just to say that Harbour porpoise are in the shallow water isn't quite enough. They are in the shallow water, but they are selecting these areas of increased rates of tidal mixing, not all the time, but during foraging, and especially during the reproductive season, which of course is critical for the survival of the species. And in British Columbia, we didn't know this until recently, but April to October does represent the reproductive season. And this is important. If we have an oil spill, and it happens to be near that 150 square kilometers of important area, and it happens to be when we've got several hundred animals in the region, for places like the Vancouver Aquarium Marine Mammal Rescue to have this information that you may have more than one or two animals that need immediate help, it's good to have this in the back of our mind when we're developing mitigation and conservation plans. But there is also a tremendous amount of information to uncover of these animals. I've spent almost 20 years working on them now, and we're just scratching the surface of what we know in this province. And what we know is based a lot on southern British Columbia, which is developed. This is where we live, it's where we are right now. But what about the areas that are developing, or the areas that are not? What's happening in between? The rest of British Columbia, we know there's Harbour porpoise, but how are they using the habitats in these areas, and how are our activities going to affect them? Because people problems are porpoise problems, because we live side by side. We don't think of them very often, unless you're me, and then I think about them almost all the time. But as you can see here, they are within sight of industrial activity. So why does this matter? Well, it does matter, because as I said, there are only 6 species of porpoise around the world. This is going to be my shameless plug for porpoise conservation. If we don't pay attention, this is the vaquita found only in the Sea of Cortez, currently listed as less than 2 years to extinction because of people problems being porpoise problems. We know why they're dying. They are dying in fish nets, and they are dying in numbers greater than what the remaining animals are able to reproduce and replace. And I was fortunate enough to be on the last expedition to try and find the last remaining vaquita. And we did, and it was really amazing. What was really sad was we found half the population in one day. And they too, just like the Harbour porpoise of British Columbia, have a very small area that's really important to them. Mexico has made it a reserve, and Mexico is doing a lot of things to try and protect this animal. And in fact, at night, if you're in the reserve and you look on the radar, you can see the perfect outline of this unusual shape lit up on the radar screen. And why? Because of the intensive fishing pressure that goes right to the border. And of course, we all know animals don't often recognize borders that people put in place. So this is just to make it hit home from Viva Vaquita. This is online. That's the population trajectory. And I would be very sad if I was here in 5 years to tell you that we had 5 species of porpoise on the planet instead of 6. So I do hope I have helped change some perceptions of porpoise, perhaps not quite as dull and uninteresting as made out to be. And I have not done this work alone. I must thank my research team and my newest member, who has already spent time with me in northern British Columbia working to identify what I think is going to be the next important reproductive habitat for the species. And so with that, I'd like to thank you all very much for your attention.
So thank you very much.
Thank you.
We can go ahead and take a few questions. If you'd like, raise your hand. I'll come on over and you can ask your question.
Just wondering if you're seeing increased rates of transient predation within these areas that are apparently critical to Harbour porpoise, since they are showing high fidelity to these limited areas.
That's a very good question. No, I haven't actually looked at it specifically, but if I would think about all the places I've seen kills, would they concentrate in those regions? No. Have I seen kills in those regions? Yes. One of my original hypotheses that related to these areas of increased tidal mixing was also, what about a refugia from predation? Because these areas are very, very noisy. And transients, as we know, are passive acoustic hunters in that they're not actively echolocating. They're listening to their world. It might secondarily be that the noise created by the turbulence of the water and the bubbles and everything might actually help Harbour porpoise forage in, I wouldn't want to say relative safety, but perhaps more safety than a quieter stretch of water.
Just wondering if do you know how many Harbour porpoises or Dall's porpoises are killed in nets in BC?
Yes, we did work on that a few years ago. And actually our rates of incidental catch in the province, when did we assess it? It was 2001, 2002, I believe, in selective salmon fisheries for commercial fishermen. And it was very low. And the thinking was, in fact, I believe it was less than 100 animals over a 5-year period, if I'm remembering correctly. Because our fisheries were quite different in British Columbia than many parts of the world, in that we have very restricted times when the nets can be in the water. They don't have very long soak times anymore. The nets are put in, and very often the fishermen are attending the net. It's not that they're unattended nets and left for days. And also the fishermen often have a practice here where they'll run the net in order to spook the fish into the net. That has the exact opposite effect with Harbour porpoise, in that boat activity sends the porpoise away. And I did work with commercial fishermen throughout the province, and they also deem it really bad luck to catch a porpoise. And so with that combined with the fishing practices and the restrictions placed on, we actually have very low incidental mortality in our province. However, having said that, you don't have to have very high rates if it happens to be an area where the porpoise are concentrated, of course. And that is seen off Washington State. There were areas that the spatial extent of the net fishery was quite small, but the incidental catch was quite high. And I know off San Juan Island, we had a massive net fishery in the late 1990s in a particular location, and we didn't see harbor porpoise there for at least 10 years after that. So it's a tricky one to address. You can say it's low province-wide, but then if they do have these very small and restricted habitats that are important to them, at least seasonally, then you can have a devastating impact quite quickly.
Okay, we've got a couple of online questions, so I'd
okay.
like to read one real quick,
Okay.
if that's all right. So I wonder if the not echolocating far enough ahead is a similar reason for so many vaquita getting tangled.
It very well could be. And there's research out of Southeast Asia with finless porpoise that indicates that when the animals are in areas that they know, that they actually reduce their rates of echolocation quite significantly, or in the daytime as well. So echolocation has a pattern often between day and night, and that pattern has been seen in Washington State as well, where rates of echolocation increase during the night, and the porpoises rely on their visual skills during the daytime. In which case, if you have nets out in the daytime, they weren't there yesterday, the porpoise isn't echolocating, they're busy foraging in what's immediately in front of them, then a net up ahead could very easily be a risk that they just blunder into. We also know from the scars and the positions of animals that have been entangled that what happens is as the porpoise is approaching the net, very often it's almost like a plane that is banking. They don't, when they're coming in, if this is the dorsal fin, they bank, and it's the dorsal fin that often gets entangled in the net, and so they're caught backwards, and then they, of course, try to free themselves, and often results in increased entanglement, and they can only remain submerged for a few minutes, so it doesn't take long.
Okay, let's go ahead and take one more online question, and then
yeah.
we'll take an audience question.
Okay.
So why the, I believe it's reverse sexual dimorphism in harbor porpoises? So compared to other toothed whales, I thought the general consensus was that toothed males are larger and females are smaller. Do you know why?
Right. Yes, that's another very good question. Okay, so if we think about Dall's porpoise and harbor porpoise, and I mentioned mating strategies, and then I didn't get into it. The male harbor porpoise has this massive production of testosterone and sperm production, and so it's thought that they will mate with multiple females. Dall's porpoise are different. They do not have that massive increase size in the testes size during the reproductive season. In fact, if you look at their body size, and then their male reproductive parts are actually relatively small. But the Dall's porpoise have huge changes in their secondary features. They get a big hump behind, or sort of on their shoulder region. Their tail stalk becomes very pronounced in the males. They're very strong. And so the male Dall's porpoise are thought to compete with each other physically, whereas the male harbor porpoise do not. So we've got two different mating strategies, multiple female partners, and then showing the females how strong you are, and perhaps mating with one or two. Off Turn Point, Stewart Island, the area that was identified at the junction, the northern Harrow Strait region between Boundary Pass and Harrow Strait, there have been sightings of what's thought to be male Dall's porpoise actually killing juveniles and newborns, tossing them out of the water. And it's probably that they're so engaged in competing with each other, and if a female gets in there and the calf is there, the calf really has very little chance at all, which to me makes sense for the female Dall's porpoise moving back into that productive area during the winter months when the males are not physically competing with each other. The other aspect is we have to remember how very small a harbor porpoise is. If we think of all of the cetaceans, this is one of the very smallest, and so they are really on the edge physiologically. And when you look at a female harbor porpoise with a a full-term calf inside of her, it really does fill much of the body cavity. So she really honestly couldn't be any smaller. And the males probably are the size that Harbour porpoise, calf-producing Harbour porpoise could be for size and cold water. So different mating strategies, and then on the edge physiologically for maintaining your internal body temperature in the cold waters that they live in.
Great. Are there some questions here in the audience?
What's the age of sexual maturity and their lifespan?
Okay, the lifespan, we really aren't sure. Off California, they're thought to live up into their 20s, but overall around the world, it's usually estimated about 10 to 12 years. Now, for much of the rest of the world, there's a very large bycatch problem. In fact, that is one of the conservation aspects that the International Union for the Conservation of Nature says we have to address bycatch around the world. So that might be reducing the overall lifespan sort of artificially because we're taking out the older animals. The age of sexual maturity seems to be between 3 to 5 years of age, depending where you are around the world.
Any more questions in our aquarium audience?
Oh, yeah.
Okay, we have 2 more.
I wonder if you could tell us quickly how you identify individuals.
Oh, yes. Actually, we largely don't identify individuals. Occasionally, you'll see an animal with a scar or something that's on the dorsal surface, but they are at the surface for a fraction of a second. And I can't tell you the number of photographs, miserable photographs of water that we have taken to get these few really good shots of the animals. And there's also work that comes out of the Harderwijk Institute in the Netherlands, where they work on Harbour porpoise and rehabilitation. And they've shown that some of the individuals that have really unique markings, those marks actually change over the time that they're in there, making things like photo identification even trickier with that 6-inch dorsal fin. Yes.
Hi, I'm just curious if you found any evidence of acoustic trauma in these guys.
That's a good one. Probably. When was it? I believe it was around 2004, although I can't remember exactly, when the USS Shoup came through Juan de Fuca Strait and Harrow Strait with it's doing some sonar work. And I don't know the details of the sonar, but I do know that I was out there that particular day, and I can tell you that it made your face hurt, it made your sinuses resonate, and it was very painful. And on that particular day, I saw more Harbour porpoise leaping out of the water than I've seen in all the years put together. In fact, it was like popcorn with porpoise and minke whales, Dall's porpoise, Harbour porpoise, minke whales, and killer whales trying to get out of the water. That's my interpretation of it. Following that event, there was a number of Harbour porpoise that were found stranded throughout the San Juan Islands, and they were examined for acoustic trauma, and the vast majority, according to the report, were stored improperly, and so there was no definitive evidence of acoustic trauma. It was probably there, because I know my ears hurt that day, and I wasn't in the water.
Would they have like a really low, or sorry, high threshold then for noise? Because if they're hanging out in areas that have all this shipping traffic, you'd think that would like, I don't know, interfere with their echolocation and everything.
Right. Okay, that's a really, really, really good point. Yes, it's very counterintuitive to think that this animal that we think of as shy and sort of staying away from people would be found in such a busy location. What I didn't mention at the beginning, and I probably should have, is that Harbour porpoise, all porpoises are what we call ultrasonic. Okay, so if we think of the frequency range of sound, we have sonic, which is the human hearing range, which ranges from about 2 to 20 kilohertz. We have infrasonic, which is below that, so gray whales, some of the larger baleen whale species. And then we have the ultrasonic, which are the porpoises. Okay, so we can hear to about 20 kilohertz. My son can. I probably can't after working in engine rooms. Harbour porpoise operate, and so do Dall's porpoise, at around 130 kilohertz. So those lower frequencies that the ships are going to produce probably don't interfere with what they're doing. Because they're using these high frequencies, one of the physical aspects of high frequency sound is it doesn't travel very far. Okay, so if you imagine, you're sitting in your car at a stoplight, and a 17-year-old pulls up beside you. It's January, you've got your windows up, but you can feel that bass coming through your car because he's really cool. Yeah, that's low frequency sound. Okay, if we were Harbour Porpoise, our hearing would be so far above that. We might feel it because it's the sound pressure wave going through us, but we would be using much higher frequencies. So this is when it gets back to the foraging, and if they're moving through moving into the incoming water, they could be echolocating but a very short distance, which also goes back to the other question about transient predation. If you're using high frequencies, you're in a noisy environment, but you only care what's immediately in front of you, those transients that are cruising down the strait probably can't hear you either, because one, the distance that high frequency sound will have attenuated, and two, you've got all that masking noise from the bubbles. So do the ships bother them? I've spent a lot of time with them in shipping lanes, and in fact had more than one situation where we're collecting data. You look up, we got to go because we got a deep sea coming down, bearing down on us, and the deep sea passes, you go back to where you were working, and they're there. I am not advocating that we fill our channels with increased levels of shipping, because Harbour Porpoise can take it, but they do seem to tolerate some levels of human activity. Some of the best groups I've ever seen have been in the shipping channels of southern BC. We also know, however, that there are some sounds that will make them leave. So the acoustic deterrents that were tested for fish farms and things like that, those sounds will make Harbour Porpoise leave an area, and they may not come back.
All right, we have time for another question here from the audience, if anyone would like to ask another question. And then we have a final question from our online audience, and then we'll go ahead and wrap up.
Okay.
It's not so much a question as I just wanted to point out that the Golden Gate Cetacean Group in San Francisco, they've ID'd around 500 individuals, I think, to date, mostly from the bridge.
Yes, and they have that wonderful vantage of looking straight down, which maybe with the new technology of these those drones that have been used,
Hexacopters.
yes, that might actually help us with Harbour Porpoise. But when you're looking side on, and you get that fleeting image. But yes, in California, they are doing some tremendous work, and they have that wonderful, wonderful platform to be able to look straight down on the animals.
Okay, our last question is about our very own Jack and Daisy that we have here at the Vancouver Aquarium. Of course, they were rescued and brought to the Marine Mammal Research Center and rehabilitated, and then brought here to the Vancouver Aquarium, as they were brought in when they were calves, so they didn't get the life skills that the adults have to forage for themselves. Are there any current research projects going on with Jack and Daisy, or just casual observation and training sessions? I'm not sure if you could answer this or not.
Well, I don't work at the aquarium, and so I'm probably not the best person to answer that. I would imagine, given the researchers that are associated with this facility, that there either is work going on or work that will be going on.
Okay, and I think we actually have somebody here,
yes, I think
our head veterinarian, Dr. Martin Helena,
yes,
who can actually say a few words about that. So I'll go ahead and pass the mic to him. And there you go, Dr. Martin Helena.
All right, thank you. Yes, there's a bunch of different things going on. Some of the exciting stuff was things you've alluded to there, Anna, as well, including ground truthing some acoustic instruments that have been used for monitoring behavior in Washington, and sort of trying to figure out a way to ground truth those instruments to find out what noises to pick up on to watch Harbour Porpoise coming across. So that's been kind of cool to watch that. There's a big disease here that's of importance. It's cryptococcosis, which is a fungal disease that's killed people on Vancouver Island, quite a devastating disease. Harbour porpoise, surprisingly, incredibly, are also prone to this disease as well. So we're very, very interested in how a pathogen that we normally associate with the terrestrial environment has made itself into the marine environment. And so Jack and Days are these incredible animals that give us the opportunity to look at immune system, and so that's underway as well as looking at basic immune function in these animals. Reproduction is so incredible, and of course you said the magic word there, which is 3 years, and that's what we're heading into with our two. So reproduction, gestation, development, all that stuff is so interesting in these animals that are, like you say, are living on the edge and using, you know, every little bit of energy. So looking at energy use and metabolics during the reproductive phase is going to be incredibly exciting for us, and you know, we're banking on them getting along for the next few years. But things look good so far. Then the other big ones are you know, in the vaquita realm, and been talking with Anna about that too. Like, where can we use these animals? How can we use these guys to help other animals endangered? And the vaquita are such that, you know, symbolic animal of that. And so where our guys come into play are net avoidance, and we've got that great study going in our Pacific white-sided dolphins with Kathy Heim, looking at acoustic and echolocation behavior and how they pick up different netting material, and hoping that can be translated into a similar study with the Harbour porpoise as we move along. And that has direct repercussions to fisheries in vaquita, which is really exciting. And then the big deal is there are so few vaquita now that it is a species where rehabilitation, reintroduction will have impacts on a population level. And so our work with our porpoise here is really, really awesome for that effort. I'm hoping that we can set up something further down the line. But those are the projects right now.
Thank you very much, Marty. And we actually also have another porpoise expert here from our killer whale adoption program, Carla Crossman. Did you want to add anything to that, Carla? Did Marty cover it?
I think he covered all the current work, yeah.
Okay, so we've got that mostly covered. So kind of just to wrap up, great talk this evening. Thank you very much, Dr. Hall. The Vancouver Aquarium has the killer whale adoption program and the BC Cetacean Sightings Network as ways that anyone who's interested in learning more about cetaceans or would like to contribute to scientific research, citizen science, and help identify and help us learn where our cetaceans live in our waters can certainly log into the BC Cetacean Sightings Network and participate and become a citizen scientist. Our next program is next week on November 18th. It's the final class for the marine life course, but anyone can watch it online for free. Or if you'd like, you can come to the Vancouver Aquarium and watch it as well. It's on seabirds and how important they are to marine life of the Pacific Northwest and here in BC. So thank you very much, everyone, for coming, and we will see you again soon. Good night.